Let me see. So this time, again, this is y is equal to log of x. This is x. This is y. And then this time, this is 1, 0, 2, 3. Okay, and then go to n. Okay, we still have this curve. We still have this curve. But strangely, we do something a little bit different. So let's say this point is n minus 1. Is that okay? So we do something in the middle. Okay. We go to this one, go up. We go to this one, go up. We go to between 2 and 3, go up. So this point is equal to 1.5. So this is the point 1.5. Is that okay? So this point is 2.5. This point is 3.5. Is that okay? Is that okay? And then for this one, we have this one. This one is n minus 1 plus 0.5. Is that okay? And then what do we do? Okay. So what do we do? So we still look at the point that 2 joins to this one. Look at the point that. So this is the value of log 2. Is that okay? This is the value of log 3. And then for this one, this is the value of log n minus 1. And this is the value of log n. Is that okay? Okay. So what we are going to do, we are going to draw a tangent line passing through this point here. Okay, we draw a tangent line passing through this point here. Okay, interestingly, this tangent line is going to be what? Going to be above this red line. Now, how do we see this? Okay, the slope of this line is going to be 1 over 2. Am I correct? On the left of this one, the slope of the curve will be 1 over 1.9, 1 over 1.8, or something like this. So it is going to be steeper. And then the curve here, on the right-hand side, the red part, is going to be 1 over 2.1, 1 over 2.2, something like this. It's going to be flatter. So you have a certain line of a certain slope, but then on this part, it's going to be steeper, steeper, steeper. On this part, it's going to be flatter, flatter, flatter. Is that okay? So in that sense, this black curve is going to be above the red curve. Does it make sense? Okay. So you hit this. So this time you get a trapezium again. And then how about this one? This one, we do the same thing. We do the same thing. This one, we are going to look at the tangent line of this one. And then we hit the curve like this. Is that okay? So in that sense, we have a lot of trapezium up to this one. And then the last one is just a rectangle. Okay. Okay. So we are going to look at the area of all the trapeziums adding up together. So it goes to those parts that hits up to the black line. So this is one trapezium. This is another one. Is that okay? These two lines may not join, may not intersect at this part, but don't worry, this is just another trapezium. We have many, many trapeziums, so there are another trapeziums here. And then the last one is a rectangle. Okay? So what do we know? So let's write down. Let's write down. So I'm going to write down first, and then let us check if it is correct. So this time I'm looking at integration of 1.5 up to n log of x dx. And then we are claiming that this is going to be less than or equal to the area of the orange part. So orange part is one trapezium, another trapezium, another trapezium, and so on and so forth. And then the last one is a rectangle. Is that okay? Is that okay? Does it make sense? So trapezium is always covering all the curves starting from 1.5 up to n. So this is the area of the curve starting from 1.5 up to n, and this is the area of the trapeziums. Is that okay? Okay, now we do the same thing. What is the area of the trapezium? So the area of the trapezium, let's take a look. So this one, so we don't know how long this is. We don't know how long this is, right? But we know what? We know what? We know it is a tangent line that hit this point. Is that okay? So what does that mean? So this part must be the average of these two. Does that make sense? Okay? Okay? So in that sense, the area of this one must be equal to the length of this one multiplied by the width of this one. So this is exactly log of 2. Log of 2. Is that okay? Okay? So the first one, log of 2. And then the next one, log of 3. Is that okay? And then up to the last one, the last trapezium. This trapezium, this value is log of n minus 1. Is that okay? So this is log of n minus 1. And finally, the last one is this one, but it is a rectangle from this one to this one. So this is half of log n. Okay? Plus log n over 2. So this time we use the same old trick. So this is going to be equal to log of n factorial minus log of n divided by 2. Is that okay? Okay, so far, yeah. So let me just double check your understanding. So this is the trapezium in general. This is the midpoint of this line. So if you cut this, so this triangle is equal to this triangle. This area is equal to this area. Is that okay? Yeah, that makes sense, right? Because this is the midpoint. So the area of this one must be equal to this height h times the width here, which is equal to 1. Okay? So far up to this point, if you are okay with everything so far, could you please raise your hand? Okay, good. Now the remaining is easy. We have what? We have the same term, log n factorial minus log n over 2. So let me copy it. So far we have this one, log of n factorial minus log of n over 2. Okay. On one side, we are saying that this is less than or equal to integration of 1 to n log of x dx. Is that okay? But on the other side, we are saying that this is going to be greater than the area of integration of 1.5 n log of x dx. Is that okay? Is that okay? So if we move this to both sides, so this is going to be, we can add log n over 2 here, and we are going to add log n over 2 here. Is that okay? Is that okay? So log of n factorial is bounded by this term and this term. And this term, what is this term? This is equal to we have computed. This is going to be equal to n log n minus n plus 1 plus log n over 2. Is that okay? And this one is equal to what? The same thing, n log n minus n, what? And then minus 1.5 log 1.5 plus 1.5 and then plus log n over 2. Is that okay? Is that okay? Does it let me double check. Okay. It looks like so. Okay. Okay. So if we look at everything together, then that means what? That means log of n factorial must be equal to, how many log n's do we have? So on the left hand side, we have n log n plus log n over 2. On the right hand side, we also have n log n plus log n over 2, right? So we must have n plus 1 over 2 log n. That we can safely assume that log n factorial has. Okay, and then we also have the same term, minus n, so we have a minus n here. Right? And then what? And then what? And then there is a term plus 1 on this side, and there is a term minus 1.5 log 1.5 plus 1.5 on that side. So it is going to be, you may be adding some k, or let's call it c, where what? Notice that this is for a fixed n. This is always true. So no matter what n you are talking about, for any fixed n, then we have a term that is related to n, and Cn, and the Cn is between 1 and some value. 1.5 minus 1.5 log 1.5. Is that okay? So this is equal to, so I've used the calculator, okay? This is something like 0.893. Is that okay? Is that okay? Okay. So now, if we take exponent on both sides, we should be able to see what does n factorial looks like. And this is our point. So we want to see, so if we take exponent on both sides, then this one, the log is gone. E to the power log of n factorial, we just have n factorial left. Is that okay? And then this will be roughly equal to, let's write it down as equal to, by the way, let's see. So we have a value of Cn here, right? We have a value of Cn here, right? So what is Cn about? Cn is, okay, let's raise the exponent first, and then I'll take some time to figure out what I want to say. Okay, so if we take the exponent of this formula, left hand side will become n factorial, right? How about the right hand side? So we can still write the equal because we're doing the same thing on both sides. Exponent of this one, okay, e to the power n plus 1 over 2 log of n. What is e to this power? So we have this very useful observation. A log b is equal to b log a. This is interesting. Why is it true? You just take log on both sides. You get log a times log b. Is that okay? So you can exchange these two. So if I am taking e to the power this whole thing, we have e to the power this one, right? So e to the power this one, I switch the e and the n. So I will get what? I will get n to the power n plus 1 over 2. Is that okay? Is that okay? And then e to the power minus n is going to be e to the power minus n. Is that okay? Is that okay? And then e to the power cn, e to the power cn. Is that okay? Okay. So this is going to be what? You have n to the power n times square root of n. So we have square root n times n to the power n. Is that okay? And then e to the power minus n is just equal to 1 over e to the power n. Is that okay? And then what is remaining? We get a term e to the power cn here. Okay? So in your exercise, so we are going to release the exercise. You have already, I guess, if you check your mailbox, then you should have got the assignment number 1. So in assignment number 1, there is a question with no marks. It's just for interest, for interest, that we can find out that this term is actually equal to square root of 2 pi as n tends to infinity. Okay, so in that sense, we get the Stirling approximation. Okay, is that okay? Good. Okay, so let us take a 10-minute break, and then I will verify what I want to tell you after the break. Okay, so let's have a 10 minutes break, and then if you have any question, please come and ask. 好，退翻了，好，太好了，好，抱歉，所以之前没有准备。对，看这个。黑色减蓝色是越来越大，这个对吗？如果你每多一个 n， 我就多一块，你可以算，你就多一点点，真的是跟以前是累加的。所以呢，如果 n 越来越大的话，黑色减蓝色的是越来越大，可以哦。所以n 越来越大，反过来了，蓝色减黑色就越来越小。蓝色减黑色的那个 term 是跟 cn 有关的。cn 是蓝色减黑色来的，所以蓝色减黑色越来越小。好 ，notes 没写错，好，应该是越来越小。所以呢，这个 cn 呢，一开始的 cn 可能搞不好很大，很接近那个1或者是那边的，然后呢，越来越小，就是小到刚刚你帮忙算的那个0.91， 0.9189，然后就停了，那这是 square of 2 pi。所以我们最重要是这边要知道，就是那个 cn 是会有 limit 的，然后有了就好了 ，OK。然后也打扰你们休息的时间了，好。那我们看到什么？看到的是什么东西的 limit 存在？就是这个 cn 的 limit 存在，对不对 ？cn 就是这两个 term 这些 term 的 difference 是越来越趋近某一个数。所以就是我们会知道，就是 limit n tends to infinity log of n factorial 减掉 n log n 减 n 会等于 cn， 这个是我们知道的，刚刚知道的，不是一开始就知道，刚刚知道的。也就是说了，这个我们可以马上得到什么？这是 limit n tends to infinity， 我把它融在一起，把它用 log 来看，所以呢，就 log of n factorial e to the power n log n 减 n 之类的。哎，不是 n log n 了 ，n 加 0.5 了，哎呀，还加个 0.5， 还加个 0.5， 会 tends to cn， 对不对？这就是我们知道，对不对？可以啊，大家知道我在写什么吗？所以呢，你两边都弄了 exponent 的话，你就会有 limit of 这个 tends to e to the power cn， 可以啊。也就是说，我们一开始讲的 n factorial 并不是跟这个绝对是越来越小，是跟它的 ratio 是越来越接近某一个数。这个是什么来 ？e to the power n log n 减 log， 这个是什么来？这个就是那个。 这个就是你把它写好一点，就是 square root of n 除以1的 n 次方。OK， 了解我的意思吗？就是从这边我们一边说它那个 limit 之类的，我们其实是 limit of 什么东西 ？limit of 这两个东西的 ratio， 我会发现 limit 这两个东西的 ratio 是越来越接近 e to the power cn。那这个在功课里面我们会知道，这个就是等于 square root of 2 pi。OK， 这个就是在功课里面会可以证的。那所以我们是有所谓的 Stirling approximation 的。OK， 好。